For time 0 to 9, what is the fewest number of times the derivative must equal 0? The fewest is huge. Give reasons for your answer. Now, derivative equals 0 means the slope is 0. So what we do is you look at this graph and we want to know when is the slope of this graph equaling 0. First of all, when is m equaling 0? How many times will m equal 0? The slope of it, or the derivative, should say maybe L prime t equals 0. How many times do we guaranteed? Now, my easiest way I think of it logically is, since this is twice differentiable, that means it's continuous. So if I just drew a continuous line through this graph, in order to do it, if I just kind of drew the graph smoothly, okay, it can go a whole bunch of different ways, but from this particular graph, you can see 3 hills and valleys, where the derivative equals 0 or hills and valleys. Maxes or mins is another great way of saying it. You can guarantee by looking at this graph, there are 3 for sure maxes or mins. There's no way to get away from it. There could be more, but there are guaranteed 3 maxes or mins just by looking at the graph. Somewhere here, somewhere here, somewhere here. And that, if you can explain it, would be fine, probably, I hope. Just trying to explain it right. But again, the technical way of defining it would be to think of mean value theorem. Meaning for these 2 points right here, what you realize is you have a slope right here. There is some point between these 2 points that have that slope. So for instance, these 2 points have a positive slope. These 2 points have a negative slope. These 2 points have a positive slope. These 2 points have a negative slope. And then what you say, basically, something like from 1 to 3, from x equals 1 to 3, all right, you have a slope that is L prime t is going to be greater than 0. Is that okay? The slope is greater than 0? There's at least a point using the mean value theorem. And from, what is it, 4? Look like 4? 4 to 7. You have the derivative is also greater than 0 using the mean value theorem. And from 3 to 4, the derivative is less than 0. And from 7 to 8, the derivative is less than 0. And what you'll try to explain with that is, due to the mean value theorem, there's slopes. And what you have to say is, from here to here, this would guarantee, oh sorry, I should have put them in order. From here to here, these 2 would guarantee a what? Wouldn't there be a max at some point right there between these 2? And then from the next one, wait, from 4 to 7 for these 2, wouldn't that guarantee a min? Kind of put them in wrong order. And then the last one, from 7 to 9, for these 2 particular, wouldn't that guarantee a max somewhere? So a max, you have 2 maxes and a min guaranteed. And maxes or mins will be derivative equal to 0, because that's what the definition of a max and min are.